Hello, my name is Yujong Kim, and today I will be presenting on the chemistry of the dental bleaching, specifically focusing on how oxidation reactions remove tissue stain caused by the organic molecule called the chromophores. As someone preparing for the dental school, I wanted to explore the chemical principle behind this common cosmetic treatment. Tooth discoloration is a common concern that leads many people to use whitening products. While enamel is inorganic, the stain we see on teeth are caused by the organic molecule. In this presentation, I will explain how stain molecules interact with teeth and how bleaching agents chemically break them down using oxidation reactions. A chromophore is a part of the molecule that absorbs the light, making it appear colored. In organic chemistry, this usually involves a conjugated pi system, meaning a structure with the alternating double and single bonds. This system absorbs the specific wavelengths of the visible light, which makes them visible as stain on teeth. When a molecule has a conjugated pi system, it creates a small energy gap between the highest occupied molecular orbital, which is HOMO, and the lowest unoccupied molecular orbital, which is LUMO. The light in the visible spectrum contains just the right amount of the energy to excite an electron from the HOMO to the LUMO. The specific wavelength of the light absorbed depends on the size of the conjugated system. More conjugation means longer wavelengths absorbed, like the red or orange, while less conjugation absorbed shorter wavelengths, like blue or violet. The color we perceive is actually the complement of the absorbed light. So if a molecule absorbs blue light, it may appear yellow. Stains often come from everyday foods and drinks like coffee, tea, red wine, and tobacco. These contain chromophores, particularly tannins and polyphenol, which have the aromatic links and conjugated structure. Stain molecules like tannins and polyphenol, which have a large conjugated system, appear dark or brown, and breaking that conjugation during bleaching makes them colorless. These features not only make them highly colored, but also able to stick to tooth surface. Even though tooth enamel is made of the inorganic hydroxyapatite, its surface isn't completely smooth. It has tiny pores and is often covered by a thin protein layer from saliva, known as the pellicle. Organic stain molecules like tannins and polyphenol have the functional groups like hydroxyl and aromatic links that help them bind to enamel in several ways. Polar groups can form bonds with the calcium or the phosphate groups in enamel, or with the protein in the pellicle through hydrogen bonding. Some chromophores may carry partial charge and interact with the ion on the tooth surface by electrostatic attraction. The nonpolar aromatic links of the distinct molecules stick to other nonpolar regions in salivary protein. In addition, these molecules are small, they can penetrate into the microscopic channels within enamel. Once they are embedded, brushing and regular cleaning are not enough to remove them, so They require chemical bleaching to break the chromophore structure. Most dental bleaching products contain either hydrogen peroxide or carbamide peroxide. This slide explains the mechanism of the hydrogen peroxide bleaching. In the mouse, hydrogen peroxide decomposes to produce a reactive oxygen species like the hydroxyl radical. These radicals are highly reactive. They seek out other molecules to react with, and in this case, they target the chromophores that cause staining. The radical break the conjugated double bonds in chromophore, which removes their ability to absorb the visible light, effectively making them colorless. This is how bleaching chemically removes the visible stain from your teeth. Carbamide peroxide is a stable compound composed of urea and hydrogen peroxide. Upon contact with the water or saliva, carbamide peroxide dissociates into urea and hydrogen peroxide, acting as an active bleaching agent. And then hydrogen peroxide decomposes into hydroxyl radicals, perhydroxyl anions, and other reactive oxygen species under alkaline condition. These radicals attack the conjugated double bonds of the organic chromophore, breaking the conjugated system that absorbs visible light. As a result, chromophores are degraded into a smaller, non-colored, which leads to the whitening of the tooth. In addition, urea increases the pH of the environment, creating an alkaline condition, which promotes the formation of the more perhydroxyl ions. This boosts the oxidative breakdown of the stain while reducing enamel demineralization compared to the acidic condition. While tooth whitening is generally effective, it's not without risk. One of the main concerns is the overuse of the peroxide, especially at high concentration, can lead to enamel erosion or increase the tooth sensitivity. Even though many people use at-home kits, improper use or prolonged exposure can damage both the enamel and the underlying dentin. Additionally, some soft tissue irritation can occur if the bleaching agent touches the gums. Another concern is the long-term effects of the repeated bleaching on enamel structure and oral health are still not fully understood. While low concentration treatments under supervision are considered safe, more data is needed to assess how long term or repeated bleaching may affect tooth integrity over time. Looking, looking forward, there is a growing interest in developing alternative bleaching systems that are less harsh than hydrogen peroxide. For example, researchers are exploring nanoparticle-based system and enzyme-assisted bleaching to reduce tissue irritation and enamel damage. A major barrier to creating the perfect whitening system is that everyone's teeth are different, stain types vary, and enamel porosity can affect how well a product works. That makes it hard to design a universal solution. And finally, we have to consider the broader social impact. Cosmetic whitening is often marketed as a beauty standard, but not everyone can afford the professional treatments. By developing safer, more affordable options, we can make the benefits of the whitening more accessible. These are the key references I use in the preparing this presentation. Thank you.